Okay, so we come to the question for the differential equation y double prime plus y equals 0, which we looked at in the preceding video, showed that y1 equals sine of x is a solution, y2 equals cosine x is a solution. We're now asking, and we showed that y1 plus y2 is a solution. That's the sum of the two functions. Is the sum of multiples of those two functions also a solution? Okay, well, what do we mean by sum of multiples of y1 and y2? That's a familiar type of question from your understanding of vector spaces. Okay, a sum of multiples of y1 and y2, we would typically, if I ask you for the sum of multiples of two vectors, v1 and v2 with arrows over them, I hope you would say, well, sum of multiples, arbitrary sum of multiples would be c1 v1 plus c2 v2. Similarly here, a sum of multiples of y1 and y2 would be c1 y1 plus c2 y2. And in this case, that would mean c1 sine x plus c2 cosine x. So now the question is, does this solve the differential equation y double prime plus y equals 0 if y equals this or this? So using this form, we substitute, we get the quantity c1 sine x plus c2 cosine x double prime second derivative plus the quantity c1 sine x plus c2 cosine x equals 0 with a question mark. Does this equal 0? Okay, well, the derivative operation does distribute over addition, so that we can break this down and say that this is c1 sine x double prime plus c2 cosine x double prime. And the rest being the same. I've kind of removed I removed the parentheses over here. Then we have the constant multiple rule, which you have experienced perhaps very recently in your calculus course. Okay, this constant multiple rule just says, well, we got a derivative, we can factor a constant number, a constant multiple of our function out of the derivative. That c1 times the derivative of c1 sine x is just c1 times the derivative of sine x. Remember, c1 is just a scalar, just a number in this case, just a real number. And the same thing is going to apply in one more step to the second derivative. So we can factor the constants out of these derivatives. We get c1 times sine x double prime plus c2 times cosine x double prime. Well, second derivative of the sine x is negative sine x. Second derivative of cosine x is negative cosine x. So now we have c1 times negative sine x plus c2 times negative cosine x plus c1 times sine x plus c2 times cosine x. And we see that c1 times negative sine x and c1 times sine x are equal and opposite, so they add up to 0. c2 cosine x, c2 times negative cosine x and c2 times cosine x again have opposite signs. They add up to 0, so everything adds up to 0. And our answer to the question, does this differential equation hold for this y? The question remaining at each step turns out to be yes, 0 equals 0, so this is an identity. So we've shown that a sum of multiples of y1 and y2 does constitute a solution of this differential equation.